Again, it's important to identify what information you know if you know the starting and ending values. So you know what the value is at time 0 and you know what the value is at time n, and there's a bunch of years in between, then you can make use of that information. 1 plus the cumulative return is simply equal to the ending value over the starting value. It basically, this expression here captures how much, if I put in how much I have for each dollar I started with. That ratio captures how much I have for each dollar that I started with, which is n years ago. So therefore, that's equal to 1 plus the compound return to the nth. So if I put in a dollar, that's how much I would have after n years. And so in order to figure out the compound return, you would take the ending value divided by the starting value, take it to the power of 1 over n. To annualize it, subtract out the 1 to be left with just the compound return. So again, you start with a dollar, you end here. Doesn't matter how you got there. All you know is that you ended there. And so the compound return is what's the return that if you got it every year for 4 years, you would also end up there. So we want to know what the compound return was over the past 6 years. You had an account that paid annual dividends and that were reinvested in the account. It's important that if you have the ending and starting values and you apply this, one of two conditions has to be met. Either any cash flows were reinvested or there were no interim cash flows. So in this case, the account paid dividends, but they were reinvested into the account, and so we can take this approach. If there were no dividends, this approach would be relevant as well. So 6 years ago you had 10,000 and today you have 16. So again, you can see that we have the ending value, which is 16,000, the starting, which was 10. 16,000 over 10,000 is 1.6. So if I had put a dollar in 6 years ago, today I would have $1.60. What's the return that if I got it each year for 6 years would get me to $1.60? So I take it to the power of 1/6 to kind of undo 6 years to figure out what has to happen for each year. Pull out the 1, so I just have the rate, and the compound return is 8.15%. And so again, if you started with 10,000 and earned 8.15% each year, you go from 10 to 10,815 to 11,696 to 12,650 to 13,681 to 14,796 to 16,001, and that's just because we rounded it to 2 decimal places. And again, it doesn't matter how you got from 10,000 to 16. You could have gone from 10,000 to 11 to 12 to 13 to 14 to 15 to 16, or you could have gone from 10,000 to 100,000 to 500,000 to a million to 10 million to 100 million to 16,000, or you could have gone from 10,000 to 5,000 to 1,000 to 100 to 50 to a dollar to 16,000. All that matters is where you started and where you ended. So let's take a look at Bear Corp. It's paid no dividends. 5 years ago it was priced at 100 and today it's priced at 60. So you can see the price went down, so we should expect a negative compound return. So again, ending value over starting value is 60 over 100, which tells us that for every dollar we invested 5 years ago, we only have 60 cents today. And we're so used to seeing that ending value over that starting value being 1.6 or 1.23 or 1.94 that it's important to look at a case where 60 over 100 is 0.6, and remember that's equal to 1 plus the cumulative return. So you take it to the power of 1/5 to undo the cumulative effect, compound effect, and you can see that you needed to have a return of negative 9.71% each year for 5 years to go from 100 to 60, so that's the compound return. And you can see if you had a return of negative 9.71, you'd go from 100 to 90.29 to 81.52 to 73.62 to 66.46 to $60.01, just due to rounding, just rounding that returned at 2 decimal places. And again, it doesn't matter how you went from 100 to 60. You could have gone from 100 to 90 to 80 to 70 to 60. You could have gone from 100 to 200 to 500 to 10,000 to 60. You could have gone from 100 to 50 to 20 to 1 to 60. It doesn't matter. You started at 100, you ended at 60 5 years later. All those paths would give you the same compound return. So we have the two averages, the geometric and the arithmetic. They're not equal. The geometric, except for one situation, and that is if the returns in every year are the same. So if we have 3 years and we have 10%, 10%, and 10%, well, the geometric average is 10% and the arithmetic average is 10%. But if we have 9%, 10%, and 11%, the arithmetic average is still 10%, but the geometric average would not equal the arithmetic, and in particular, it would be slightly less than the arithmetic. So the only time the two averages are equal is in a case like that where the return in every single year is the same and there's no variation. Once you get some variation, then the geometric will be different, and in particular, it will be less than the arithmetic.